In the early 1930s, inside a busy building in New York, people were amazed as something new appeared in front of them. An elevator door that opened automatically when they walked near it. No button pressed, no human doorman, just light, doing the job silently. That was the birth of one of the most revolutionary devices in automation history, the photoelectric sensor. At that time, engineers were experimenting with light beams and photocells, trying to create safety mechanisms for elevators. Their discovery laid the foundation for a technology that would one day control conveyor belts, packaging lines, robotic arms, and even automatic doors in your local supermarket. Today, this same invisible light-based technology runs deep inside factories, ensuring every object is detected, every bottle is filled correctly, and every robot knows exactly where to stop. All happens autonomously with the help of a most important product, called an photoelectric sensor. But what exactly is a photoelectric sensor? And how does it see without eyes? Let's open this mystery. Welcome back to Mr. Smart. At its core, a photoelectric sensor is an electronic eye, a device that uses light to detect the presence, position, or movement of an object, all without touching it. It's made up of two main parts: an emitter that sends out a beam of light, and a receiver that looks for that light. When the beam travels freely from the emitter to the receiver, the system assumes the path is clear. No object is present. But the moment something interrupts, reflects, or scatters that light, the receiver instantly senses a change. This tiny change in light intensity is then converted into an electrical signal, which can tell a machine to stop, start, count, or sort. And this is where the real magic begins. Inside a small photoelectric sensor housing, you'll find some fascinating components working in harmony. The light source, often an infrared LED or a laser diode, emits a steady beam of light. It's like the sensor's flashlight, invisible to the human eye in most cases, but perfectly visible to its own receiver. Then comes the photodetector, usually a photodiode or a phototransistor, that acts as the eye, converting the incoming light into an electrical current. Between these two, a signal processing circuit continuously compares the received light strength with a reference value. Whenever that light pattern changes, the circuit instantly switches the output. This output, in turn, connects to a PLC or controller, triggering logic operations, such as stopping a conveyor, activating a counter, or turning on a solenoid. All of this happens within milliseconds, far faster than the blink of a human eye. Over the years, engineers developed different types of photoelectric sensors depending on how the light beam interacts with the target. The first and most reliable design is called the through-beam type. Here the emitter and receiver are placed opposite each other, with a continuous light beam traveling between them. When nothing is in between, the receiver sees the light clearly. But as soon as an object passes through the path, the light is blocked, and the sensor immediately knows something's there. This type can detect objects several meters away, and is commonly used for counting products on fast-moving conveyors, detecting pallets, or ensuring safety barriers in factories. Its accuracy is excellent, but installation needs precision, Both emitter and receiver must be perfectly aligned, like aiming a laser at a pinpoint target. The second type is known as the retroreflective sensor. Here, both the emitter and receiver are combined into a single housing, while a special reflector is placed opposite to bounce the light back. Under normal conditions, the emitted beam hits the reflector and returns to the receiver. But when an object blocks the beam, the light doesn't return, and the sensor detects its presence. This type is easier to mount since only one sensor is installed, and the reflector does the rest. You'll find retroreflective sensors in automatic door systems, packaging machines, and elevators, exactly where it all began nearly a century ago. Then comes the third type, the diffuse reflective sensor. In this design, there's no reflector at all. The sensor emits light and waits for it to bounce back, directly from the object itself. When the object comes near, its surface reflects some portion of light to the receiver, and detection occurs. This is why it's also known as a proximity photosensor. It's the simplest to install. Just point it at the area you want to monitor. But its sensing range is limited, usually just a few centimeters. Its performance also depends on the object's color and material. Shiny surfaces reflect more light, while dark ones absorb it. Still, in short-distance automation tasks like robotic pick-and-place systems, part detection, and sorting units, diffuse sensors are the go-to choice. But technology didn't stop there. As industries demanded greater precision and intelligence, photoelectric sensors evolved into smart sensors, capable of not just detecting, but also measuring. Today, we have laser-based photoelectric sensors that can detect objects even millimeters apart, background suppression sensors that can ignore shiny conveyor surfaces, color and contrast sensors that help packaging lines detect print marks, and even analog output sensors that can continuously measure the distance of an object instead of just telling yes or no. These advancements have turned simple optical eyes into intelligent systems, key components in industrial automation, robotics, and smart manufacturing. To understand how significant they are, just look around. When you walk through a mall and the door slides open, that's a retroreflective photoelectric sensor. When bottles move on a filling line, being counted and capped precisely, dozens of photoelectric sensors are working behind the scenes. When you park your car and the gate lifts automatically, that's another sensor watching the vehicle. Even in elevators, escalators, vending machines, and packaging robots, these sensors silently ensure everything works in perfect timing. Their operation is simple in theory, just light and detection, but their impact on automation is extraordinary. They've reduced mechanical wear by avoiding contact, increased safety by detecting presence instantly, and brought accuracy that humans alone could never achieve. So, from the first elevator door in 1931 to today's smart factories filled with robotic eyes, the journey of photoelectric sensors shows how a small beam of light can illuminate the entire world of automation. Because sometimes the most powerful technologies aren't the ones that make noise. They're the ones that quietly see everything. Don't forget to like the video and subscribe, Mr. Smart, for more interesting technology insights.